This is the mission 44, organized by Space Analog Station Habitat Marte. Today is July 13th, and we will have the presentation about the launch center, and also JAWS will be related to engineering center. And then it's very good presentations and also contributions to space exploration, more based in to create a Mars habitat. And then in this mission we have Nikita from India, Nicholas from Germany, and Arvin from Philippines. And everybody are welcome. Okay, Varsha, you are welcome to start your presentation. Okay.
Amazing. Thanks, Julia. Screen. There we go. Okay. My screen okay for everyone?
Perfect.
Yes, good.
Alrighty. So this was a presentation that was first made for mission 43. Over there, but I'm going to skip over that. That was a couple of weeks ago. My name is Varsha, and let's dive right into it. So this is about the launch center. So I wanted to kind of explore some of the concepts around what a launch center will necessarily need. And this is kind of where the presentation is going to start out at. The very first thing was around the need for reusable rockets to travel to and fro Earth and Mars, or some intermediary point between Earth and Mars. Because if you can imagine, this vehicle would need to not only escape Earth's gravity, complete a mission that would last anywhere between 6 to 9 months long, descend through Martian atmosphere, stay on the surface for whatever amount of time it would need to complete its mission, which means it would have to withstand really low temperatures, go through possible dust storms, as well as constant radiation. And it would need to carry enough fuel on board for at least a trip from Earth to Mars and back to Earth again, because we don't want those ships permanently stationed on Mars, because where are they going to go after that? And we know that the launch window opens up every 26 months. Worst case scenario, that ship is going to need on Mars for that amount of period of time and be able to continue to make a journey onward after that. Any initial experiments would have to be done with cargo only, if only to make sure that we have any of the glitches around autonomous navigation and guidance kind of sorted out. It will need to be closed loop, because most of that journey, like a large part of that journey, is going to be done with significant delays to communication. We're looking at anywhere between like 3 to 24 minutes of a lag. And one interesting possibility that I was looking into was this idea that when you have cargo only, the ship perhaps does not need to descend back through Earth's gravity on a return. It could meet like an orbiter and kind of pass on its cargo to that vehicle as well, which brings its own different set of challenges in, because now we're talking about like coming up a couple of feet close to another vehicle, releasing your own cargo, and making sure that the other vehicle kind of meets it in such a position that it's able to grab hold of this cargo and like secure it in place. A whole bunch of challenges there. But in terms of the fueling that would be required, now traditionally solid fuel motors, we're all like we're very comfortable, very familiar with operation of solid fuel motors. It's what's been driving all the previous Mars orbiters. So Spirit, Opportunity, Curiosity, all of them have had solid fuel. The SpaceX vehicles, Falcon 9 or what have you, have all been liquid methane. Again, we're just as familiar with them as just solid fuel motors, a little more stable, not but liquid fuel, of course, is a lot cheaper. The cons of using either of these two systems is that they need to be kept pretty stable at warm temperatures, which means that for any launch station or any base on Mars, you're going to have to supply constant energy for that warming. And the other one, of course, is like single start. So if for any reason you need to have increased maneuverability during that journey between Earth and Mars, it's not the most optimal choice. So the possibility of hybrid system motors, where you basically have a solid fuel. I'm going to see if I can. Oh, I don't have a pointer because it's not Excel. My bad. But if you can see my mouse pointer over here, you have solid fuel, solid fuel, kind of wax-based, as well as oxides of nitrogen as a liquid oxidizer over there. The idea is that as and when you would need the thrust, the oxidizer is injected into the solid fuel, ignited, and then provides you that amount of thrust. But because this process is not as quick as igniting a solid fuel, obtaining large amounts of thrust at small intervals continues to be a challenge. That being said, it's super stable at really low temperatures, so that's a big win for anything that's going to be stationed on Mars. And there are a couple other challenges that kind of need to be sorted out before we're quite so sure that hybrid system motors are the way to go. Some of these are going to be common to other ships, regardless of fuel choice. For example, like the design of the nozzle itself, to make sure that regardless of how many landings it does, it doesn't quite break down on us. So in terms of how I envision the launch center kind of being divided into multiple functional areas, you have the main launch area over here. This is the main area where ships would arrive and depart from. We'll talk about methane and water production next to the launch center pretty quickly, but both of these goods would need to be stored. Of course, you'd want the methane to be, this is going to be liquid methane, but you probably want this to be decoupled from the rest of the launch area. You don't want any flammable goods nearby. So it's probably going to be an underground facility, slightly more removed from the rest of the habitat. A transportation center to deliveries and cargo that arrives at the launch center and deliver it and scatter it through the rest of the habitat. Traffic control and scheduling. So this is the optimistic view that we are going to have so many ships coming and going from Mars that we are going to need some form of active traffic control to make sure that ships are not colliding and such. Just like you'd have an ATC for every airport on Earth here, you want something similar on Mars. Kitchen or relaxation area, just like an area that every person that's manning this launch center can actually de-stress and kind of complete other activities outside of main work. Not just for like eating and sleeping, but also for mental well-being. And the last area that I have here is a robot shelter and a machinery maintenance section. We're gonna see a lot more of this at the rest of the presentation, but a large part of the activities in this center is going to be performed autonomously, which means we're going to have quite a large amount of time being dedicated to maintenance and upkeep. And sheltering any of the more mobile robots that can be kept away from dust storms and radiation. just an example of how some of these could look like. But the main launch center, I imagine, would be a dome-like structure that could open and close to receive vehicles. The benefit of having of it being closed during like non-receipt of vehicles would mean that you're minimizing the amount of dust damage, as well as any potential damage from radiation. Now we kind of come to the section of like how we're going to build and maintain the habitat. So one of the really cool things is that the landing pad in the main launch center um, gets subjected to a lot of abuse. So any arriving vehicle is going to have its engine plume kind of crater and create a bunch of dust because of that, because of the ground beneath it. What we want to try and do is avoid and minimize the amount of flying dust and dirt that we have. Curiosity had one of its instruments actually damaged because of the flying dirt from engine plumes as it was descending. We want to make sure that that doesn't happen because it can be a lot more serious when it's not just a smaller rover. So some of the ways that it can be done. Um, One really cool thing is if your nozzle itself has is able to spray out liquid metallic content. So in this case, we're talking about alumina. Um, the initial tests that were done with this particular experiment was a spray of nearly like 310 kgs of alumina in about 15 seconds. As soon as it hits the Martian surface, it cools due to the really low temperature, forming like a hardened landing pad area that really minimizes the amount of dirt that gets pooped out of when as a ship is descending. There is some amount of cratering, but it's much more reduced. Another option, likely to be much cheaper, only because like now you're not requiring each vehicle to carry its own quantity of alumina in flight through the entire mission, is if you have robots kind of running around and paving the area with each landing that occurs, just making sure that there's a harder surface on top of the Martian regolith that doesn't allow it to be pulled out. This example is just this image that I've shown you here is actually just a basalt paving. Obviously, we're going to have to think of other materials that can be mined out of Mars itself. Okay. Now, as we went back here, over here around like methane and water storage, and we said we would talk about where that methane and water was coming from. This is kind of the section that covers that. So fuel generation. What I imagine is that we're going to have a swarm of modular robots, so much smaller mining robots. This is one concept of how a mining robot would look like. This is based on an experiment from a research center based out of NASA right now, and they call this the RASA robot. So what you have here is um, two two mining moving parts on either end of the bot that actually do have teeth, and that's responsible for actually digging up the regoliths. In the center here, you have rotating drums. So each time if you can imagine the claws, as they dig in and as they scoop up the dirt, they kind of drop it into the drum and continue onwards. When the drum is full, the robot senses it, and it's ready to deposit its contents at the fuel generation center. Now, the moving parts would need to be maintained so that excessive dust doesn't get accumulated in there. That comes back to the whole like robot shelter and the maintenance section. Tests so far have been conducted at a much smaller scale, and the initial RASA robot is actually quite large. So in order to do something at a much larger scale, I believe that you really want something that's a lot smaller so that each individual mining bot is smaller, lighter, easier to build and maintain, But it can couple with hundreds, maybe thousands of these in a very swarm-like capability, autonomously guided, of course. You can really scale out that operation. Also, so far, we haven't really found the teeth, so these claws, um, teeth that can handle not just a smaller mix of ice with regolith, but much higher quantities as well, which makes it a lot harder. We don't want those teeth really breaking on us, because finding replacement parts for that is, well, you're going to have to wait for equipment to arrive from Earth to replace something like that. So as soon as those drums get full up, the bot kind of finds its way to the main production center. Um, Again, like as I said, you'd want this to be a deployment of a large swarm for efficient production, completely decentralized algorithmic control. Um, so the cool thing about this drum-like setup is that it turns one way to mine, and it reverses its way to deposit any collected regolith. And it drops it into this hopper arm. The hopper arm kind of feeds itself, and we see what happens next. Basically, what it's doing is heating up the regolith, which is mixed up with water. It's electrolyzed into its components, hydrogen and oxygen. The liquid hydrogen is what's going to serve as fuel, but we don't want to store liquid hydrogen as is because it's fairly unstable, and just storage is a lot more complicated. So it's mixed in with carbon, which is extremely abundant in the Martian atmosphere. Close to like 95% of the atmosphere is carbon dioxide. You want to mix that in to create methane, and then methane is what is stored in that methane storage area, again, underground and hopefully isolated from the rest of the habitat. Any water that's generated as a byproduct of the reaction itself is transferred into containers and kind of shipped across the rest of the habitat for consumption by the rest of the facilities, which is kind of where the transportation center also comes in to schedule and coordinate movement across the facility. Righty. In terms of the things that the functionalities that we need to develop in the launch center, receiving ships and people and preparing for their departure would require us to figure out how fueling occurs, the transport of that liquid methane, and like fueling up the machinery itself, maintenance of any equipment that's required, scheduling of these arriving and departing ships, traffic control, as well as the ability to secure our ships during adverse environmental conditions. Now, granted that the dome-like facility might not require us to do that, but for any reason, if that dome cannot be closed, or if the ship was not able to make its landing in the required area, you still need to make sure that like it doesn't topple over. So during a dust storm, say, like we're going through right now, because once toppled over, then it just becomes a much more arduous task to bring it back upright for it to leave. Any logistics and transportation and delivery the habitat that have arrived from any of the ships, as well as building and maintaining the launch pad, and any of the machinery and sensors that are required for our robotic swarm during the excavation of regolith. And the duties of our position. So we are going to need some on-site aerospace engineers in our launch facility itself for fueling maintenance and securing ships, logistics and communication stuff for traffic control, scheduling, communications, as well as robotics engineers for maintenance of our swarm and the launch pad robots. Things that we would want to develop in our facility. A lot of what I focused on here is things around protocols of communication and safety drills. Only because launch center, again, we're talking about rather precarious areas of the facility coupled with areas where you would want people to kind of relax. So making sure that everyone is well prepared for the most negative scenario that happen is super important. Some of that is going to be enhanced by just monitoring and reporting on a regular basis for equipment and system health. Knowing what our schedule for arrival and departure is well in advance, as well as developing communication protocols, not just within the habitat, but also with Earth. Um, because again, we're looking at significant like communication time delays. Just knowing when and how we expect our communications to kind of go through standard messaging format in case any parts of the communication get missed out and such. Um, we're going to have regular delivery runs of cargo from the launch center to the rest of the habitat as well. Obviously, during our dust storm, that's going to be paused because we don't want that to continue as is. Um, Transport of any water that we've generated during the excavation process throughout the rest of the facilities, as well as anything that involves regular upkeep of any of our machinery. Um, and this is kind of where I'm really hoping to emphasize the use of swarms, because you do want spare parts to be swappable and modular. When things break down, you want to be able to beg and borrow from your other systems as well, thereby not relying completely only um, on new items that are arriving from Earth. And guidelines to be provided to the other facilities and the rest of the whole station. And the emphasis is on communication protocols, as well as the ability to coordinate between the rest of the facilities in the habitat, any shortfalls that might occur. In this case, just water, but in the case of the greenhouse, let's say, you're talking about coordinating additional requirements for, let's say, food and such. But that protocol can be reused across the rest of the station. And doing the same for any mechanical spare parts and replacement. And possible activities to be applied to our daily lives. There is so much that we can learn by imagining what facilities on another planet can look like. Just some of the ones that I've listed here are um, knowing how to develop our facilities in a way such that you are reusing and adapting to materials that are available locally, as opposed to expending fuel and time in transporting raw materials and equipment from other parts of the planet. I know it becomes a little harder given how established and entrenched our global supply chains are on Earth, which in some cases means that transporting equipment from over 1,000 kilometers away often tends to be cheaper than using local materials. But there are significant advantages of staying local, and they're not all climate change related. Consuming the least amount of resources to accomplish the task at hand, just really having this mentality that resources are not unlimited, which of course it'll be a mindset that's absolutely like inculcated in Mars, because you're talking about a much harsher habitat, but really using that same mindset back on Earth as well. Because yes, the resources are a lot more, but that still doesn't mean that they're unlimited, especially if we're thinking about Earth as now being an interplanetary species and needing to share some of that out just Earth. An attempt to minimize impact of technology on the habitat. We want to decrease destruction and reduce the amount of negative impact. There's I don't really feel like I need to justify that point. Feels kind of obvious. And the thing about this, about having a swarm of mining robots, as opposed to larger individual pieces of machinery like we have here on Earth, which works because Earth's gravity supports us having really large, heavy mining machinery. But it's not quite the same on Mars, of course, because it's got like 38% of Earth's gravity. So what you're looking at is the development of smaller, lighter, modular components that can be swapped in and out for each other, um, reducing danger to human life. But also because they're smaller and modular, you reduce the spend on spare parts. And because you're much larger in number, because you're looking at a robotic swarm, if a couple of bots go down, it has zero impact on the operation itself. which is absolutely what we'll have to do on Mars, because you do not want to depend on any one single machinery dictating the health of your facility. And that's all I had for today.
Okay, Varsha, thanks so much for your presentation. One question that I like to know, can you imagine how many astronauts would be necessary to operate the facility? Or maybe if you be answered after, or thinking about, and maybe answered about it during the mission. Okay, not it's not necessary answer today, but I'd like to know how many persons are necessary for the entire research station.
I actually did think about this last time as well, and I was looking at about 7 people. The launch area and the traffic control having 2 each, and kind of swapping out shifts, only because those well, I envision that it's going to be somewhat continuous for a large period of time. Just operating in shifts, because those are going to be pretty high in demand. Every other place, the shelter maintenance, transport and logistics, and for the storage areas each, you'd have one person each kind of manning them, but it's going to be on a non-continuous basis. So it allows the folks on the station itself to kind of swap in and out with each other's um, duties.
Okay, thanks so much. More questions?
Yeah. Oh, sorry. Go ahead, Nicholas.
Thanks a lot. I've got one question. So how much fuel do you need to generate in order to be able to get back to Earth? And how long does the generation process take approximately? So I know it depends on the scaling factor, but is there like a rough number, like 1 day or 1 week or so?
So I'm going to start that question with an "it depends," and then hopefully we can kind of work through what that answer is. So the fuel entirely depends on the size of the vehicle, the payload that it's carrying. But let's kind of start with a made up number. But because the whole mining process itself is not something that has been scaled to any amount that can be compared, I'm going to kind of throw out a ballpark, only because I'm assuming our swarm is, let's say, 1,000 bots, assuming we have some kind of modularity in it. I'd imagine it would take anywhere between a couple of weeks to a month, accommodating for inclement weather as well, because it's not going to be a continuous operation, I'd imagine.
Yeah, makes sense. Perfect. Thanks. Yeah.
So, Varsha, I thought it was a really excellent presentation. I really enjoyed the bit about the razors. That was really cool.
Yeah.
So I had a little question about the Earth orbiter. So I was wondering if you considered maybe the pros and cons of that versus using the moon as a kind of interim step between the Earth and then going to Mars.
It's a really good point. As opposed to a pros and cons, I'd actually think it's I don't necessarily think we'll have to pick one or the other. I believe that the way things are going, there is a desire to establish some kind of go-between between Moon and Earth, only to provide a short stop fueling station, etc. on the Moon. I'd imagine eventually we still will want a large proportion of our ships and cargo to be brought back down to Earth, because that's it's still going to be the one place that you kind of fuel up or pick up spare parts from. But having a go-between at the Moon itself has been something that's been discussed for sure. And along the same lines as having something similar for Mars at Deimos or Phobos has also been discussed. I remember the last time we were talking about this. We also talked about space elevators, which is amazing. But yeah, they call them space lines because they're not truly elevators because they're not connected at both ends. But yeah. And there's already talk of having like of what that structure would look like between the Earth and the Moon. I'd imagine that is something that can be extended between like Mars and Phobos as well.
Cool, thank you.
I also have a question, Varsha, about